I'll start then. I'm Cindy Quillen. I'm one of the ECE advisors. I'm technically the lead academic advisor. My special group is study abroad. So for any of those who are interested in study abroad, you will probably want to talk to me at some point.
Hello, my name is Yuxiang Wang, an academic advisor and an international student support coordinator. I also advise exchange students, even though we have no exchange student here now. Okay.
Thanks. So now I guess us ambassadors can introduce ourselves. So hello, my name is Zach Vandermissen. Currently I'm a PhD student here at Purdue, although I also did an undergraduate degree at Purdue in electrical engineering.
Hey guys, my name is Altai and I'm a sophomore in electrical engineering right now. That's all.
All right, hi everyone, my name is Naveen and I am currently a junior in electrical engineering and math.
Hi
Thanks,
guys,
I'm sorry, Tanya.
You're good. I am a computer engineering student. I am a senior here in the ECE department.
Thank you, Tanya, and everyone else. All right, so I'll start sharing the slides for the presentation now. Of course, you all know we're from the Electrical and Computer Engineering Department. And the biggest question we get asked from people that are looking at electrical and computer engineering is, how are they different? So these next couple of slides addresses that, as well as how they relate to computer science. So the two different degree programs that we offer have a lot of parts that overlap. And this is kind of a high-level overview. You see that computer engineering has a couple different places that you can emphasize, whether that be software-focused or hardware-focused or a mixture based on which classes you take. The plan of study has more classes which are required as compared to the electrical engineering one, which has a few more places where you get to make a choice. And electrical engineering has a list of defined focus areas. These aren't, I guess, like the specializations like the aeronautical engineering program has that are rigid, but all the classes are sorted into these different areas, 7 of which we have in electrical engineering. And these kind of help organize the courses and give you different places to target the choices that you make. And this is another way to kind of help understand the difference. There's sort of a spectrum from the level of detail on mathematics and physics and really the small individual devices that make up electrical and computer engineering systems up to higher, more abstract concepts. And that's sort of the flow from electrical engineering towards computer engineering. And so you can see some of the things on the slides here, designing the devices themselves and transistors and fundamental physics things is really the base off of which electrical engineering is built. And as the systems get bigger and more integrated and more complex, you start involving into computer engineering. And when you get to systems that are very large and very complicated, or just whole dedicated computer systems and software and networks of systems like AI and cloud computing, these are things that are at the far end of the computer engineering spectrum. And one more slide that we use to relate these topics is looking at a similar spectrum, kind of comparing computer science with computer engineering. So of course, computer science is in a different college, not our department, but there's lots of overlap between computer engineering and computer science. And you can kind of view this the same way that the last slide has a spectrum from things that are more grounded and tied into hardware and physical objects and smaller, more discrete systems, and evolving into larger, more complicated systems, as well as systems that have more abstract concepts or even really kind of fundamental investigations into how programming and computers work, like studying programming languages, things of this nature. And I will bounce back to the previous slide. There are people that study anything in the middle of this that are under a computer engineering umbrella or under electrical engineering umbrella. And likewise, you could find people studying really almost any of these topics under a computer science umbrella or a computer engineering umbrella. There's really a kind of smooth continuum between these three fields in the kind of topics that they address, because they are all closely related. So would one of the other ambassadors like to start talking about some of the electrical engineering focus areas?
Yeah, okay, I can take this one. So again, in case I haven't mentioned it before, hi, my name is Naveen. I'm a junior in electrical engineering, and I want to say there are 6 electrical engineering focuses, maybe 7. And essentially, automatic controls one. I have a few friends doing this. It mainly focuses on robotics. So if you're interested, so I know a lot of people, especially from high school, have done FIRST robotics. And I know, especially coming from FIRST robotics, it's a super common track to go down the automatic controls. You take a ECE 382 is the main class. That's one of your core EE classes that I mean, you're not required to take it, but I don't know how the new plan of study works, but at least on mine, there are like 5 classes out of which you have to pick 3. ECE 382 is one of them. Communications, I know I'm probably going to be doing EC 438 next semester. I've heard really good things about DSP, and in general, it's just supposed to be a good class to have. Fiber and optics, this is actually one of the specializations that I've not heard a lot of people doing, but I am currently in EC 30411, which is sort of like electromagnetics 1, and that's a pretty interesting course so far.
This is actually the field in which I'm working on a PhD, so I can hop a little bit on this. It's really a really high demand job market right now. People to work on wireless hardware, wireless communication systems, radars, space internet, things like this. It's a really burgeoning field that needs more engineers in it than we have right now. So it's a good focus if you want to be part of a hot job market.
I'm doing VLSI and circuit design. So I took EC 337 last semester. It's a really, really interesting class for anyone. So in case, just to give you a little bit of context, there's a class that most people take their sophomore year, second semester called EC 270, which is Introduction to Digital Design. And EC 337 builds off of that heavily and sort of goes into a little bit more into digital design and sort of focuses on, in case you don't know what ASIC stands for, it stands for Application Specific Integrated Circuits. So think of it as if EC 270 teaches you the fundamentals of like digital circuit design, and then 337 focuses on more custom applications. Like, for example, our final project last semester was to build part of a USB module. So sort of those custom circuits that, you know, have a very, very specific application. And right now I'm in EC 437, which is computer design and prototyping, which is essentially the undergrad equivalent of computer architecture. And that's a really, really interesting class, and that heavily focuses on EC 337 and 362.
Another interesting thing to note here is you see computer engineering listed as an electrical engineering focus area, and that's not a mistake. You're able to take many computer engineering labeled courses as part of an electrical engineering degree, and they'll count towards lots of your degree requirements. And actually, as you move on into the graduate program in our department, they both merge into one general ECE degree, and all 7 of these focus areas are kind of treated as their own full independent sections. So if you're interested in computer engineering, but you're not sure you want to be fully committed to it, you can take some of the classes and take other non-computer engineering, electrical engineering classes under that banner.
So I can hop on this slide. So if you are more interested in the computer engineering track here at the ECE department, we do have a lot of courses that are really good to develop your skills. So one is microprocessor systems and interfacing, which is ECE 362. It's a lab course and a lecture course, and you're going to learn about computer organization, the instructions that you can do with a microprocessor, assembly language programming. So that's kind of the very low level programming that you learn in that course. And then we have ECE 49595, which is a software engineering tools laboratory. And then there's computer design and prototyping. You learn about data path design, control strategies, memory hierarchy, networking. That's ECE 437.
So this is, I guess, a newer thing in the department. There is now a 4+1 degree offered. So what this means is for the commitment of only 1 extra year beyond your bachelor's, you also complete this dual program and you get a non-thesis master's degree. So this is something you might have heard of. A couple different schools had these previously, and now there's one in ECE as well. There's a lot of great time savings in this if completing that non-thesis master's degree is something you're interested in, because there are a set of courses that help count towards both the undergraduate and the graduate degree. And from my personal experience, and I think the numbers would show that 1.5 years to 2 years would be a typical completion time for a non-thesis master's. And so you do really kind of save the whole year there by going through this program.
So I think I can hop in. So where's EC? EC has a lot of buildings located among campus, and the two main ones are the MSE building, which is the Material Science and Electrical Engineering building. It's the newest one, and we have a nice design studio here that only EC students can get in. And besides that, we have the Electrical Engineering building, the traditional one, which has most of the labs and stuff. And I believe in the next slide, yeah, this was the design studio I was talking about. It's located in the MSW building. And as I mentioned, most of the EC labs are located in E. And besides that, my peers just mentioned that electrical engineering has a focus area of nanotechnology. So we have the Brick Nanotechnology Center. I believe it's on State Street. So if you're interested in that area, you'll get to work in that building. And we also have the Wang Hall, and that's the graduate building for EC.
So as you can see from the numbers that are on the slides, ECE is very big at Purdue. 107 faculty is a very large number for a school in any place in any university. And you can see that combined, we have over 2,000 students in our program as well. And not only are we large, but we're also extremely successful. Our undergraduate programs are both in the top 10 in the nation. And we've been reliably very highly ranked for decades at this point. So coming into Purdue ECE, there is a lot of opportunity that giant size grants you, and it's a fairly high quality program.
Yeah, so I can hop on this slide. So the department does offer a lot of scholarships, and you can start applying to them once you've been admitted into the program for ECE. So you can get it for your sophomore year, your junior year, and your senior year. They'll send out a form to your email that you just fill out. It's very merit-based. You'll have to answer questions regarding your GPA, fill out things related to any leadership commitments that you've made, any community service, any clubs that you're a part of on campus, talk about any internships that you've potentially done, and you'll hear back over the summer. And you know, you can get a scholarship between 500 to 2K, 2,500, if not more, from the department. So everyone should apply to these scholarships because a lot of students do get one of these scholarships. They do have a lot available.
And our advisors always love to show the number that there are more students in ECE than there are people who apply for these scholarships. So you can't get any money if you don't apply. So if you're coming to ECE, once you've been accepted into the school, absolutely please apply for these.
Okay, I can hop in here. So Purdue offers in general many study abroad opportunities. Besides the general study abroad, you can have an EC study abroad, which you can convert into EC credits. And the popular destinations for that is Switzerland, Singapore, Spain, United Kingdom. And most of these countries have English language teaching, so you don't need to speak their specific language if you want to go study abroad there. You can either choose to be there for a year, a single semester, or you can even do summer study abroad.
Another great thing about having such a large school is we have some very active student organizations, and it's not just one ECE club, but there's several of them. So you're seeing all of us here, members of the ECE Student Society's Ambassadors subgroup. Although the ECE Student Society has a whole collection of things that go on, the Women in ECE Committee is very large. The Multicultural Affairs Committee and Spark Challenge Committee are both active. So beyond our general student society, there's the Honor Society for ECE, Eta Kappa Nu, and there is IEEE. And IEEE is a professional organization in electrical and computer engineering, and their student branch here at Purdue does educational activities, projects, some of which go to national, international competitions, as well as outreach events in the community. And you see here a photo from the annual HKN versus IEEE flag football game, because even ECE students sometimes play sports.
Okay, I can take this slide. So I've actually done, I've done 3 of these things. So my freshman year, first semester, so that was fall 2018, I did EPIC, so I was part of the Camp Riley team. And in general, I know a lot of students in FYE are heavily involved in EPICs, but I know upperclassmen also do it. And I also know that it's offered as a senior design option as well. So if there's any particular EPICs group that you're interested in, I believe you take 2 credit hours each semester during your last 2 semesters at Purdue, and that can count as your senior design. Then undergraduate research within the EC department, there's a lot of opportunity for undergraduate research. Professors are really nice, especially when it comes to, even if it's not to do research with them, they're just good to talk to about research. Like, for example, I've gone to multiple EC professors' office hours to be like, hey, I'm interested in this field. What would you suggest I do? And then they suggest me to read a book, or even sometimes ask me to come back maybe in like a week or 2 saying if I'm interested in research opportunities, and they could talk about it further. VIP is, it stands for Vertically Integrated Projects. It's essentially, the reason it's called Vertically Integrated Projects is because it allows all graduating classes to sort of collaborate on a student project. Like, I'm part of, it's this organization called Cam Squared. It's headed by Dr. Yongshang Liu. He's a professor in EC. He teaches EC 264. And he has a VIP team. And essentially, I have collaborated with graduate students, PhD students, freshmen, sophomore, junior, literally every graduating class. And SURF stands for Summer Undergraduate Research Fellowship. That's essentially, I believe they give you a stipend over the summer to do research with a particular professor at Purdue. I think the applications were due last week, if I'm not wrong. I think it was like around early Feb. I'm not exactly sure about the date. And DURI stands for Discovery Undergraduate Research Internship, which is offered during the summer, spring, and fall. And it's, I believe you do research with Discovery Park, and I think you can either do it for pay or for credit. I don't remember that off the top of my head, but.
So there are a lot of choices for senior design in the ECE department, and I break these up into what I would call currently the 2 major options and the 2 less common options and 1 new option. So what's called electrical engineering senior design and digital systems senior design are the 2 most often taken choices. They're actually both available to both electrical and computer engineers. That one name is a bit of a misnomer. They both offer a team experience where you work typically on a team of 4 people to design over the course of a semester product that you design and prototype and demonstrate. They mostly differ in the way that you form the team. Digital systems you form beforehand, and electrical engineering senior design you form during the very beginning of the class. It was mentioned that EPICS is a senior design option that you can do through ECE, and also participation in a vertically integrated projects team in a kind of similar way. You can use that as a senior design option. There's a newer option that is just starting now called computer software senior design. And this is an initiative being developed by the department to look at design projects that are significantly more, if not entirely, software based, whereas the other 2 options usually have a mixture of software and hardware, sometimes predominantly hardware. This is a dedicated opportunity to look at software based design projects. If none of the other ambassadors, I don't think I have any blurb about this. Maybe an advisor could jump in a little bit on computer software senior design if you have that.
Okay. It is going to be, currently the plan is it'll only be available spring semesters. You have to have a team of 3 and you work with the instructor to get pre-approved. Just like 477, that's a team of 4 and you have to work with those instructors to get pre-approved to take the class. And the new name for it is open source software.
Thank you. So these are a mixture of ECE projects that come from VIP, different design classes, and senior design classes. The CAM Squared team, which was just mentioned, is one of the VIP projects. System on Chip Extension, Autonomous Land Vehicle, and Access are all actually VIP teams as well. And this is a couple of different demonstrations of projects. I believe that the Light Show project and the robot project are from the microcontroller systems class, whereas the laser engraver is from our senior design course. I believe that was from the digital system senior design.
So yeah, as the Purdue EC grads, we have a wide selection of opportunities to work, and these include like multinational companies, and like I'm pretty sure you are familiar with most of these companies. We have graduates working in those places, so you will have a chance to work in those companies if you graduate from EC.
And the best way to get a chance to work at one of those companies is through the career fair opportunities that you have here at Purdue. So there's a good chance you've heard of Industrial Roundtable, which just about every company that comes to IR will be seeking ECE majors of some type. There are just almost every company needs somebody in some ECE capacity. Boilermaker Circuit is another slightly more targeted opportunity. It's just for ECE students. It's put on through the school, excuse me. And all the companies that are showing up specifically want to hire Purdue ECE students for their internships or their full-time opportunities. And so it's nice having that exclusive job fair that makes it easier to get good conversations with the recruiters. And this freshly updated list is always hotly sought after information. Do you want to talk about it, Tanya?
Yeah, so these are the average starting salaries for the two majors in our department. So computer engineers starting salaries around 85, 86K. And electrical is 72, almost 73K. And you can see that out of the several engineering majors offered at our school, these are the top two. And these statistics are from 2019. So I'm sure they've either stayed the same or gotten better since then. So yeah, so you're definitely in good hands post-graduation once you graduate from Purdue and have completed all your coursework.
So there's a chance that a couple of these names might be recognizable to some of you attendees. We've got a few famous names around Purdue. Michael Burke has several things named after him, like the Burke Nanotechnology Center and the Burke Boilermaker Gulf Complex. And we're always, of course, very proud of our astronauts, Eugene Cernan and David Wolf. And former CEO of McDonald's, Donald Thompson, is another very active Purdue alumni. He's back on campus from time to time. All of them ECE alums from Purdue. So this is really kind of our summary wrap-up slide. So we've kind of thrown out a bunch of information about different parts of our program and different things you can do with it and what opportunities coming to ECE will unlock for you. If you're still trying to determine, what interests you in engineering, think about these 4 big themes, which are electronics, technology, innovation, automation. Things that are along these lines, things that build out from these, things that include these kinds of ideas are the types of things that you could go on to work in if you come to ECE. And it's a very broad field. There's a wealth of opportunities in more specialties than we have time to name off. So it's very, very possible that if any of this appeals to you, that there is something for you to do and enjoy in ECE at Purdue. So I believe, thank you. It's going to be open questions for the remainder of the presentation, unless any of the ambassadors or advisors wanted to add any other closing statements before we take questions. Okay, well, seeing none, hopping into the question queue in chat, we'll get through all of them. So just starting from the top. Let's see, how difficult is it to get into CompE? Is there a space restriction in this program? No, at this time, none of ECE's programs have a space restriction. The requirement to get into ECE has been in all previous T2M cycles equivalent to meeting the requirements to complete first-year engineering, and I believe that is still the case. This is a 2.0 GPA and meeting the required course requirements to complete first-year engineering. However, this offer and promise always comes with a warning. Be aware that coming into ECE with a 2.0 GPA is the minimum requirement, and you will need to work hard to improve yourself academically. Expect, if you're coming in with a flat 2.0 GPA, that you may struggle quite a bit in your first couple of semesters in ECE. ECE, because of this large and generous acceptance policy, also has the highest drop coda rate of any of the engineering schools. Because this is a challenging program, though we accept many people, you need to put the work in when you come here.
I think I can answer the second question. So someone asked, are these buildings shared between EC and CompE? So all EC students can use all of these buildings once you get into the major. But currently we have some restrictions because of the pandemic, and you will not be allowed into some of the buildings or labs. But I assume next year you guys will be able to get into all the buildings and the design studios, except the Nanotechnology Center. You're just allowed there if you are working in the area of nanotechnology.
Let's see, a couple of overlap and repeat questions. Could an advisor confirm that I believe, yes, the requirements for T2M in spring and summer semesters are comparable? I don't think there's any different requirements.
No, that is set by FYE, and whatever semester you transition, the requirements are the same. And again, just a 2.0 and complete all the FYE 9 required courses, and we will take you.
And ECE has a very good year-round course calendar, not just fall and spring, but also summer, for all of the courses that you would need for your first and really second year in the program. So whenever you start, you really aren't going to be behind. You can get your schedule on track from any semester in ECE, which is a great benefit.
I'm going to jump on to what Naveen said in the chat. Technically, you can actually double major in electrical engineering and computer engineering, but it is strongly not in your best interest. I don't know how you would explain it to potential employers or grad schools. And we would make you be here 6 years because we will not let you double count the ECE classes. So 362 is an advanced selective and upper level lab for an EE. It's a core for a CompE. Doesn't count both ways. So you end up having to take like 78 ECE credits. Get a master's in one, undergrad in the other. You're here the same amount of time, spending the same amount of money. Do not ever double major in electrical and computer engineering. We've had one student do it, never did figure out why.
Yeah. Something that I'm seeing, just to really hammer it home, there is nothing else you need to do other than to apply for T2M to this program to get accepted to it if you have that GPA and have completed the courses that FYU needs you to complete to be leaving FYE. What is the best minor addition to a CompE degree? This, I'm sure, is a subject of hot debate and everyone could have an opinion. The best minor addition to your degree is the one that makes you happy and you enjoyed taking. It is truly rare that a minor will help you get a job or prevent you from getting a job. Minor courses, minor concentrations, fully completed minors even, are a marginal effect on a resume at best. So take minors that make you happy. Don't finish a minor if it's not making you happy.
Yeah, I can add to that. Yeah, students added different minors. Math, physics, entrepreneurship, business, economics, things like that. So a ECE major with math or physics, I think it's a kind of addition. Others like business management or even liberal arts, I think it's a complementary. Yeah.
Next question that we have is GPA connected to the possibility of getting an internship? Yes, absolutely. Many companies have corporate policies that have minimum GPAs that are acceptable for hiring interns, and some very selective companies have bars as high as 3.5. They will not consider below that. There are lots of companies that will consider people with GPAs as low as 2.8, even 2.5, but the better your GPA, the more opportunities are open to you. What percentage of undergraduate students will go to graduate school after they finish 4 years of undergraduate school? I don't have that figure in my pocket. Does anyone?
I'm the keeper of the senior exit survey stats. I'd say it for our international students, it's probably 30–40% go to grad school. For our domestic students, that number is significantly lower. Most of our domestic students don't go to grad school.
Next question, would ECE or ME be better if I'm interested in robotics? Tough question to answer. You can't go wrong either way. Both have strong robotics offerings. It depends a little bit about what is most interesting to you. If like the arms and the actuators and the mechanical design and the really complex linkages are what's interesting to you, then maybe mechanical engineering is a better route. If like the automation software and the controls and the AI and the programming is what's interesting to you, maybe coming through electrical engineering is the better route. One thing that we always say at this point is mechanical engineering does not offer a minor, and people that want to go into robotics often look at a mechanical engineering minor as a good way to get some of those extra classes in that help complement the electrical engineering degree. The reverse isn't true though. Electrical engineering still offers a minor. So if you're into robotics and you are really on the fence, we do often suggest thinking about doing mechanical engineering, electrical engineering minor, just because the reverse isn't available right now at Purdue. Let's see, for T2M GPA, are only FYE courses considered or are others as well? I don't know that technicality. I think it's full GPA?
You have an EAI, Engineering Admission Index, and that's the 9 required FYE courses, Cap 1, Cap 2, Physics 1, Chem 1, Engineering 1, Engineering 2, and Written Communication and Oral Communication. You have to have a 2.0 for that. And I think you have to have an overall 2.0, and you get those and we'll take you.
All right. Let's see. Is it possible to do AI in EE, or should I just go to ECE? If by ECE you mean computer engineering, I would say at least with the research distribution, more people doing AI fall under the computer engineering umbrella. But if just doing AI is most interesting to you, I would definitely look at the course offerings and see which way you could fit them in better, because there are options under computer engineering, but there's also definitely courses that are not AI that you'd be required to take. So just looking at the plan of study and seeing how it would be easiest to fit courses in to get those courses of interest to you in would be a good choice. Both EE and CompE would be a fine decision, I think. Can I do a mechanical major with a minor in computer engineering? Yes, that is permitted. Or rather, I should excuse me. I think there's a general minor for electrical and computer engineering, which has the same list from which you can draw courses. So you could try to focus on CompE courses from that list, but it is just one same program. Let's see. We have gotten to the bottom of our question stack, and we still have a few more minutes that we have committed to sharing your time. We've got a question here. I've heard that you can't major in Comp E and minor in CS, but you can major in EE and minor in CS. This previously was the status quo. There is an open ongoing discussion of very recent history discussing between computer science department and electrical and computer engineering department about details about how this might change going forward. At the moment, that is still a true statement. However, there might be a modification of that in the future. The reason that that happened was the courses that are in the Comp E minor are basically a list of computer engineering core courses, very, very similar courses offered in the other college. So they didn't want you to take the same classes twice and earn a minor in the process. It probably wasn't going to be a good use of your time, and it didn't really broaden your education too much. But they're looking at options at the moment. How can a sophomore who will T2M into Comp E after this summer graduate in 4 years? So I guess this is a little bit fact specific. If you'd managed to start taking any ECE classes ahead of time, and I guess that would be a critical part of it, because the first semester does kind of choke back a lot of the progression. You do need to start taking some of those base foundational classes. And Comp E's critical path in terms of what you must take before the next class and after the next class to get to the final class is longer than EE's. If you're in the situation where you're finishing your second year at Purdue T2Ming and you haven't started the ECE curriculum, I do not think there would be a way to complete the whole Comp E curriculum in 2 years that didn't include summers. And even then, you might be up against like a hard critical pathing limit. So I would definitely get in touch with someone from the ECE advising office and look at a 2-year plan if that's the situation you're in. There's a way possibly to get that in for you, but it'll probably take at least one, if not both of those summers.
I can tell you, even if you haven't T2M'd, we will let you take ECE classes if you have met the prerequisites. So we won't hold you up if like you only need one more class to complete the T2M process and you can fit in an ECE class at the same time. Go for it. We will support that.
Yeah. Helpful question. What is T2M? T2M is an abbreviation for the transition to major process, where you move from the general first-year engineering program to one of the various professional targeted engineering programs. So that's the step out of FYE into, in this case, electrical or computer engineering. So it's not a class. It's just a couple of forms that get filled out and some emails that get sent back at some point, and then an advising appointment. One topic that is commonly asked about is the kind of next transition to major in life, moving on from undergraduate into graduate school, if grad school is something that's interesting to you. And I guess, how do you prepare for that? And are there things you can do to do that better? But we'll follow that up after answering this student question. I saw that many of the second-year Comp E courses only have co-recs instead of prereqs that were completed in FYE. Hence, is it advisable to take 18 credits worth of ECE courses in one semester? No, no. Look at all the shaking heads from every single person in that gallery. 18 credits of ECE in a single semester, while I'm sure if we dug through the record books, we could find someone that did that with like a 3.5 GPA, the typical highly successful student would struggle profoundly and probably not succeed. That is too many classes of ECE. Anything beyond 12 ECE credits in a semester is really stepping on the gas, and even 12 can be a lot if it's a challenging or high time commitment class. Honestly, like 8 to 12 is what a lot of people shoot for as a maximum. Let's see, I'm finishing FYE this summer. I still can get into ECE Comp E on time. Yes, so yes, that is something that you can just get registered for the fall semester like you had T2M'd in the spring. And if your summer T2M goes through as you plan, then you'll be right on track. And comparable question, last FYE class in the summer, can I register for ECE classes for the fall? Yes, they'll help you get that set up. So to return to the tangent about grad school, let's see, or to not to return to that tangent, is it possible or viable to take a completely different field of engineering for grad school, ECE undergrad, aero, and grad school? It does happen in both into and out of ECE directions, but that only happens in places where the fields touch. So micro and nanotechnology is a big overlap between material science and electrical engineering and mechanical engineering to some extent, and chemical engineering. Somebody that has an undergraduate degree in any of those fields in that area could easily have a graduate degree in one of the other ones. There's lots of other places where majors touch like that. Robotics is a big one. There's also a ton of places from computer engineering that you might move into a CS graduate program, but that's how it happens. It's where the fields overlap and require both kinds of expertise. Not I focused on automatic controls and I'm going to go into thrust propulsion design as a grad program. That's not really the kind of direction that normally happens. Some ECE classes, oh yeah, that was a comment from Naveen. Cool. All right, so as I was saying about grad school, many grad schools are selective about GPA. Keeping up your GPA is one of the easiest things that you can do to help increase your odds into getting into competitive, high-quality grad school programs. The next most valuable thing beyond keeping a reasonably good GPA in this context, I would say a 3.5 makes you qualified for really any program, and a 3.8 makes you competitive for any program. Just very rough numbers. However, I've known people with as low as a 3 or a 2.9 that have gotten accepted into very high quality grad programs. It depends a lot on other factors. The next biggest factor beyond GPA is, have you done undergraduate research experience and how did that go? With the exception of coursework only masters, all the other degree offerings are going to have some sort of a research component. So if you can show a grad school, I've done research before, it went well, it resulted in this kind of an academic publication, or I worked with this professor and this is the project that I completed, that is going to really move mountains in a grad school application. So using one of those opportunities that were discussed for undergraduate research, like VIP or directly with a professor, is the easiest way to prepare yourself for graduate school applications, because if you can say, hey, look, I can do the thing that I need to go do when I'm in grad school, then they'll snap you right up. They love seeing students that have undergraduate research experience that was successful. Really, those are probably the two most heavily contributing factors. The other one that would be is have a plan with what you're doing with your degree. Computer engineering does have a lot of choices in it, and electrical engineering has even more choices in it. If you just kind of roll a dice and pick courses at random from the lists and it technically completes the degree requirements, you will get a piece of paper, but you might not have prepared yourself to be really effective in a job field or a graduate field. So if you kind of make a plan, like I'm going to take some courses from automatic control and an additional set of courses from micro nano area, just kind of picking a couple areas and focusing down on there and taking some higher level classes. That's another good way to be prepared both for jobs and for grad school, is to kind of, you know, tell a story, prepare yourself for something specific with the classes you've taken. How can I get undergraduate research experience? So registering for the Vertically Integrated Projects VIP class is guaranteed undergraduate research experience. You can sign up for it like a class and you will be paired with a research project as an undergrad. It's a great gateway into getting into a one-on-one relationship with a professor or just getting your feet wet. It is a little less intimidating and a little easier to set up than a direct relationship with a professor. So VIP class is my biggest recommendation for getting started. To get an internship, is there anything else required or helpful except GPA? Having a skill that is useful to the company that they're hiring you to use. So the earlier you go into your career, the fewer classes that have advanced like techniques and pieces of knowledge that are really, you know, related to ECE. The things that are most marketable early, you know, freshman summer, sophomore summer, tend to be more programming related. The first two internships I got were mostly programming, occasionally informed by some other stuff I'd learned in class, but it was mostly programming. So that's not 100% of it. I don't know if anyone else had an internship that wasn't programming in their first couple of summers. If you want to talk about what you did. Okay then. Let's see. How do you recommend doing research such as VIP in sophomore year? You can. There's not really a wrong time to try it. It's kind of wherever it fits in your schedule. If you have a busy semester, maybe don't try it for the first time during that semester, but sophomore year isn't too soon. And another thing is, a lot of people think that they might be interested in research, then try it once, and it is not for them. And so having that first learning experience, ideally before you are applying to grad schools, is really good for you, because you get to learn whether or not research is for you, and don't accidentally go to grad school if it wasn't what you wanted.
Hey, Zach, is now a good time to post the QR code while we get the last questions
that
answered?
Sounds good.
Can we see this okay?
Yep, that looks crisp to me.
So if any students have issues with the QR code, leave your name and Purdue email in the chat, and make sure you send it to everyone. If you send it to me, I won't be able to go back later and find it. Anyone that has an iPhone should be able to just get their camera out and take a picture or scan it.
Wait, sorry, you said we should put our names in the. Oh, don't worry.
No, so if you can't scan it, leave your name and Purdue email in the chat.
Somebody in the chat is asking, what is the password for the QR code? Is there a password in the form?
So it's your Purdue password. Don't use the PIN code. Yeah, it's the school login.
Oh, your standard password then.
Yeah, not the 4-number PIN and the push, but the actual password.
And I guess looks like we're really wrapping up answering the chat questions. Us ambassadors were on schedule to stay around until at least 6:30. So although the crowd will be getting released from this event soon, if anyone had, specific or direct questions for anybody, we're available for another few minutes after everyone's going to get released.